Good day, everyone. In our previous lesson, we learned how sequences and series are applied to loan and mortgage payments. Today, we will continue exploring another real-life application of these concepts: investments. Specifically, we will learn how to determine the value and the accumulated value of investments over time using arithmetic and geometric sequences and series. Let us begin. Suppose you have 5,000 pesos to invest today. You are given two investment plans. Plan A earns 500 pesos more every year. Plan B earns 10% more than the previous year's earnings every year. Now, think about the following questions. Which investment grows by a fixed amount? The answer is Plan A because the increase is always 500 pesos every year. Next, which investment grows by a fixed percentage? The answer is Plan B because the investment increases by 10% every year. Now, which investment forms an arithmetic sequence? Since Plan A increases by the same amount every year, it forms an arithmetic sequence. Finally, which investment forms a geometric sequence? Since Plan B increases by the same percentage every year, it forms a geometric sequence. As we proceed with today's lesson, remember this simple guide. A fixed amount means arithmetic. A fixed percentage means geometric. At the end of this lesson, you should be able to identify investment patterns that form arithmetic or geometric sequences. You should also be able to determine the value and the accumulated value of investments over time using sequences and series. Finally, you should be able to solve real-life investment problems involving arithmetic and geometric growth. Before solving investment problems, let us first review the arithmetic sequence. An arithmetic sequence is a sequence in which the difference between consecutive terms is always constant. The formula is A sub n equals A sub 1 plus open parenthesis n minus 1 close parenthesis times d. Here, A sub 1 is the first term. D is the common difference. And n represents the position of the term. Whenever an investment increases by the same amount every period, we use this formula. Remember another important guide. If the problem asks for the value during a particular year, we are looking for only one term of the sequence. Therefore, we use the sequence formula. A geometric sequence is a sequence in which the ratio between consecutive terms remains constant. The formula is A sub n equals A sub 1 times r raised to the quantity n minus 1. Here, A sub 1 is the first term. R is the common ratio, and n is the position of the term. Whenever an investment grows by the same percentage every period, we use this formula. As we proceed with today's lesson, remember one simple guide. If the problem asks for the value during a particular year, we will use a sequence formula because we are looking for only one value. If the problem asks for the accumulated value from the first year up to a certain year, we will use a series formula because we are finding the sum of several values. We will see this distinction more clearly in the examples. Now let us define the important terms that we will use throughout this lesson. An investment is money placed in a financial instrument with the expectation that it will grow over time. Some common examples of investments are savings accounts, time deposits, mutual funds, and bonds. As your investment grows over time, its value changes from one year to another. Sometimes we are interested in knowing the value during a particular year. At other times, we are interested in knowing the accumulated value from the first year up to a certain year. Throughout today's lesson, always pay close attention to what the problem is asking because that will help you decide which mathematical formula to use. Let us solve our first example. Maria invests money whose value increases by 1,000 pesos every year. During the first year, the investment is worth 20,000 pesos. Find the value of the investment during the 8th year. Notice the keyword value. Since we are looking for only 1 year's value, we will use the arithmetic sequence formula. The first value is 20,000 pesos. The common difference is 1,000 pesos. The year we want is year 8. Let us substitute these values into the formula. Using the arithmetic sequence formula. A sub 8 equals 20,000 plus open parenthesis 8 minus 1 close parenthesis times 1,000. First, subtract 1 from 8. That gives us 7. Next, multiply 7 by 1000. The result is 7,000. Finally, add 7,000 to 20,000. Therefore, the value of Maria's investment during the 8th year is 27,000 pesos. Notice that we found only one value, so the sequence formula was the correct formula to use. Now let us answer another question using the same information. This time, find the accumulated value from the 1st year to the 8th year. Notice that the question did not ask for the value during the 8th year. Instead, it asks for the accumulated value from year 1 to year 8. This means we are adding the values from every year. Because we are finding the sum of several terms, we will use the arithmetic series formula. We already know that the first value is 20,000 pesos, and from the previous example, we found that the 8th year value is 27,000 pesos. There are 8 years in all. Now, let us substitute these values into the arithmetic series formula. Using the arithmetic series formula, S sub 8 equals 8 divided by 2 times the quantity 20,000 plus 27,000. First, divide 8 by 2. That gives us 4. Next, add 20,000 and 27,000. The result is 47,000. Finally, multiply 4 by 47,000. Therefore, the accumulated value from the 1st year to the 8th year is 188,000 pesos. Again, remember the difference between the two examples. In example 1, we found the value during one specific year, so we used the sequence formula. In example 2, we found the accumulated value from the 1st year to the 8th year, so we used the series formula. Always pay attention to these keywords because they will help you choose the correct formula. Let us solve another example. John invests 10,000 pesos in a business venture. The value of his investment increases by 20% every year. Find the value of the investment after 6 years. Notice the phrase value after 6 years. Since we are looking for only one value, we will use the geometric sequence formula. The first value is 10,000 pesos. The common ratio is 1.2, because a 20% increase means the investment becomes 120% of its previous value. The year we are looking for is the 6th year. Now let us substitute these values into the formula. Using the geometric sequence formula, a sub 6 equals 10,000 times 1.2, raised to the quantity 6 minus 1. First, subtract 1 from 6. That gives us 5. Next, evaluate 1.2 raised to the 5th power. The result is approximately 2.48832. Now multiply this value by 10,000. Therefore, the value of John's investment after 6 years is approximately 24,883 pesos and 20 centavos. Notice that the investment increased by the same percentage every year. That is why we used the geometric sequence formula instead of the arithmetic sequence formula. Let us summarize the key concepts that we learned in today's lesson. An investment is money placed in a financial instrument with the expectation of earning returns over time. When an investment increases by a fixed amount, it follows an arithmetic sequence. The value of an arithmetic investment can be determined using the nth term formula, while its accumulated value can be determined using the arithmetic series formula. On the other hand, when an investment grows by a fixed percentage, it follows a geometric sequence. The value of a geometric investment is determined using the geometric sequence formula. These concepts allow us to analyze how investments grow over time and help us solve practical financial problems involving savings and investments. Before we end today's lesson, let us reflect on what we have learned. Suppose you have two investment options. One investment increases by a fixed amount every year. The other investment increases by a fixed percentage every year. Which investment would you choose if your goal is to maximize the growth of your money over a long period? The better choice is the investment that increases by a fixed percentage every year. This is because the investment experiences compound growth. Each year's increase is based on the investment's current value, causing the amount of increase to become larger over time. In contrast, an investment that increases by a fixed amount grows at a constant rate, Although it continues to increase, its growth is slower than an investment that grows by a fixed percentage over a long period. Therefore, when all other factors are the same and the investment is allowed to grow over many years, an investment with a fixed percentage increase generally produces a greater future value. This is one reason why understanding geometric sequences is important in personal finance and investing. That concludes our lesson for today. We learned how sequences and series can be applied not only to loan and mortgage payments but also to investments. I hope that today's lesson helped you appreciate how mathematics can be applied in real-life financial situations. Thank you for your active participation. Have a wonderful day, and see you in our next lesson.